Hello everyone. In our previous lecture, we had covered about the laws of motion, and the conservation laws. In this lecture, we are going to cover about the thermodynamics and also for the electromagnetism. So let's start. So basically, what do you mean by thermodynamics? So thermodynamics is a branch of science which deals with the heat and energy behavior. Okay. So basically, thermodynamics is a branch of science which deals with the heat and the energy behavior. Okay. Or you can say how heat can be used for performing various activities. Okay. So in this section of the thermodynamics, we are going to know about some laws of the thermodynamics, starting with the first law of thermodynamics. First law of thermodynamics. So remember, in our previous lecture, I had told you about the conservation of energy, right? And what does this law mean? This law means the energy could not be created. The energy could neither be created nor be destroyed. Or we can say energy could neither be created nor be destroyed, right? It was the conservation of energy. Okay, it could only be transformed from one form to another form. Similarly, the first law of thermodynamics gives the same statement that the energy cannot be created or destroyed. It can only change from one form to another form. So let's take an example first. Suppose there is a object. There is a object which comprise energy A. Okay, with 100 units of energy, or basically energy could be measured by unit joule. So you can say 100 joule of energy. 100 joule of energy. Okay. After some time, you put this object into some work like rotating the fan. Rotating the fan. Then you will notice the energy of this object is now around 50 joule. So you will say that the energy is getting depleting or the energy is destroying. But in our statement of the laws, we stated that the energy cannot be created or destroyed. Then how the energy is going down from 100 to 50? That's the main question. And this is the reason, because of transformation. Okay. So let's assume this box is inverter. You know what is inverter? Inverters which we use at home to use in the absence of the electricity supply. Okay. So this box was an inverter basically. And if the inverter start with the 100 joule of energy and start rotating the fan, then after some time you will notice its power is getting decreased and it is nearly about 15 joule, because first it has chemical energy. Inverters has chemical energy, and when it start moving the fan, it was transferring the chemical energy into the electrical energy, and the electrical energy was transferred into the wind energy. Okay. So basically, this was the complete graph of the transformation of the energy in this example. Okay. So you can say the amount of energy getting depleted from 100 joule to 50 joule would be transferred to the electric energy, and thereafter the wind energy, because the fan is giving you the wind. Got it? So this is the basic example of this example of energy. Got it? So now let's take another example first. Imagine you have a toy car and you push it to make it move. The energy you put in by pushing changes into the car's motion energy, making it move. Now, when the car stops, its motion energy changes into another form, like sound and heat. The energy doesn't go away, it just changes into different things. So let's take an example. Let's take an example into action. Suppose this was the car. At first, it was put at height, and because of this position, as I had told you in a previous lecture, it could be a potential energy. Okay, and when you pushed it, it will start moving down. Okay, and with moving down, the potential energy is getting converted into kinetic energy. Okay, but after some time, when this car would reach plane area, it will get stopped. It will get stopped because the potential energy will be first transferred into kinetic energy for the movement, and with the movement, because it will have an impact of friction. It will have an impact of friction. This kinetic energy will be converted into heat energy and sound energy. Okay, and when the consumption of kinetic energy will be disappeared into heat and sound, this car will get stopped. Okay, so the question is, what do you mean by friction in this case? Okay, friction basically means opposite force to motion. Opposite force to motion. So you can say, if anything is in motion, like this person is in motion in this direction, then there would be opposite force of motion in this direction, which we'll call friction. So basically, you can say the friction is the opposite force applied on the motion. Okay. Let's take another example. Remember, in our previous lecture, I had told you, if this was the car, if it is in rest, then it will be in rest until or unless some external force pushing on it, because of the first law of motion. So when you push it, it will start moving. But after some time, it will get stopped until or unless the force would be in constant nature. If the force is not in the constant nature, the car will get stopped eventually. Okay? Why? The constant nature of force is required, because when the car will be moving in this direction, there will be a force in its opposite direction, which we call the friction. And with the constant effect of friction, eventually the car will get stopped if the force is not applying constantly. Got it? So now let's come to the second law of thermodynamics. Second law of thermodynamics basically means heat naturally flows from hot things to colder things, and some energy gets lost along the way. Here, remember one thing which I am telling you, it's temperature. It's temperature. So what do you mean by temperature? Temperature is basically measurement of heat. Measurement of heat. Okay. Suppose if there are two objects, object A and object B. This object comprise some heat. This object comprise some heat. If I ask you, just tell me which object has a more heat. How would you be able to tell me which object has some more heat in comparison with the other object? Then you require some measurement, and the measurement of degree. And this measurement of degree is known as temperature. Okay. Temperature is basically measured in various thermometer units like the Celsius, Fahrenheit, Kelvin, Reaumur, and Rankine. Okay. So these are the thermometer units where the temperature is measured. Okay. But from exam point of view, we only know about Kelvin, Celsius, Fahrenheit, and Kelvin. Okay. So these are some major thermometers which are used to measure the temperature. Okay. So now let's come to the topic. If I ask you which object has more heat, then you must require to measure the temperature of that object. Got it? And temperature could be measured in these 5 thermometers, and the important thermometers are Celsius, thereafter the Fahrenheit, then Kelvin, and then Kelvin. Okay. Now the another question is, if these thermometers are used to measure the temperature, then they must have their lowest unit and highest unit, right? They must have their lowest unit and the highest unit on which these temperature could be measured. Okay. So let's understand the highest and the lowest unit of these thermometers. So for Celsius, the lowest point is, the highest point is 0 degree Celsius, and for this 100 degree Celsius. Got it? And for Fahrenheit, the lowest and the highest points are 32 degree Fahrenheit and 212 degree Fahrenheit. Got it? And in case of Kelvin, the lowest point and the highest point are 273 Kelvin, and the highest is 373 Kelvin. Okay. So these are the highest and the lowest point of these temperature measuring scales. For Celsius, with the lowest and the highest is 0 degree Celsius, and 100 degrees Celsius. For Fahrenheit, it is 32 degree Fahrenheit to 212 degree Fahrenheit. And for Kelvin, it is 273 Kelvin to 373 Kelvin. Got it? So now let's back to our question. So if I ask you, how could you measure the temperature of these bodies? Then you could tell me that for A, the temperature is 32 degrees Celsius, 78 degree Fahrenheit to 78 degree Kelvin. Okay. And for B is, the temperature is 70 degrees Celsius, then 100 degree Fahrenheit, then 315 degree Kelvin. Okay. So just remember, for A and B, these temperature scales is just for example. Okay. There is no relation between them. They are just for an examples. Got it? So if you compare these values, whether in Celsius, Fahrenheit, or in Kelvin, same for the B, then what do you think? Which of these objects has the more heat in comparison with other? Then the answer will be B. So the B object has some more heat. Got it? So this is about the measurement of the heat, which I had told you. Now, the second question is, or you can say the second fact, not question exactly. The second fact is that there is always a flow of heat from high heat area to low heat area, or you can say from high temperature to low temperature. Okay. So there is always a flow from high heat area to low heat area, or you can also say from high temperature to low temperature. Okay. It is the general statement. It is a general statement, and the second law of motion, second law of thermodynamics, sorry, not motion, thermodynamics. Heat naturally flows from hot things to colder things, and some energy gets lost along the way. Okay. So now let's understand it by an example. By an example. Okay. Suppose if there are two bodies, one body, and this is second body, and this is second body. This body is A, this body is B. Okay. Suppose in this body the temperature is 38 degrees Celsius, and in this body the temperature is only 8 degrees Celsius. So when it's come to the heat, what do you think? Which body has more heat? Obviously body B. And which body has low heat? Obviously body A. Okay. And as our statement says, there is always a flow from high temperature to low temperature. Okay. So similarly, the flow will be there from higher to low, from higher to low. Okay. So it was an example for the first statement, like heat naturally flows from hot things to the colder things. Got it? But what about the second? So let's understand the second phenomenon. It's B. Suppose the B carries heat of 100 Joule, just for example. And because it was a hotter body, then the flow will be from B to A. So if the heat is getting transferred from B to A, then there should be a complete transfer of these 100 joules. But only 80 joules reaches there. Just only 80 joules reaches there. Why? Because some heat get lost in the air while the movement is going on. So it is an example for the second statement as well. Got it? So now let's take another example. Like this example. Think about a hot bowl of soup. As it sits, it starts to cool down. This because the heat from the hot soup is moving into the colder air around it. It's like when you leave a warm cookie on the table and it's become colder. Heat always moves from warm things to cold things, making everything reach the same temperature eventually. Got it? So let's change the example into action. The first is for the soup. Suppose it was a bottle of the soup. It was the bottle of the soup which was around 50 degrees Celsius hot. Okay. And there are the surrounding of the soup. Surrounding, or you can say the atmosphere, whatever you would call it will be the same. Atmosphere. The temperature of atmosphere is only 30 degrees Celsius. So what is going on? The soup bottle which we put inside the atmosphere having a temperature of 50 degrees Celsius, whereas the atmosphere which surrounding the soup ball having a temperature of only 30 degrees Celsius. Got it? So in this scenario, there will be a flow. There will be a flow from high to low as per the law. Okay. And here the soup ball is in high temperature. This atmosphere is in low temperature. Okay. So the transfer of heat will begin from bowl to surroundings. And this flow will continue till both the surroundings and the the soup ball and the surroundings or the atmosphere get the same temperature. So let's suppose the soup ball having temperature of 15 degrees Celsius and the surroundings having a temperature of 30 degrees Celsius only. Okay. So the soup bottle transferred nearly about 10 degree to the atmosphere. Okay. So here the new temperature will be 40 degree in this bottle, and here the new temperature will be 40 degree in the surroundings, because minus 10 plus 10 happening there. Okay. So in this scenario, both the bowl temperature and the atmosphere temperature get equal. So this transfer of heat will be stopped. Got it? So this is about the first statement of the hot soup. Now let's also understand the second statement for the hot cookie. For the hot cookie, suppose you left the hot cookie which having a temperature nearly about 30 degrees Celsius, just an example, and the surroundings where it was kept having a temperature of only 10 degrees Celsius. So here again, the cookie has more temperature, whereas the surrounding has lower temperature. So let's suppose the cookie lost 10 degree. The new temperature will be 20 degree, whereas 10 plus 10, the new temperature of atmosphere will be 20 degree. Got it? So as per the new scenario, after the transferring of heat, the cooking temperature will be 20 degrees Celsius and the surrounding temperature will also be 20 degrees Celsius because minus 10 was happened there and plus 10 was happened there. Got it? So here we have finished the second law of thermodynamics. Now come to the third law. As things get colder and colder, it becomes harder to reach absolute zero, the coldest temperature possible. Okay. So basically, it means that when the object start cooling down and the object start cooling down, then it could only reach up to the certain point, up to the certain point only, okay, which we call the absolute zero, the coldest temperature possible. Okay, sorry, we can say it could only reach up to the certain point, not absolute zero, the coldest temperature ever possible. So basically, this law states that when the object is starting cooling down, could only get cool up to the certain point. When inside temperature, when the inside temperature will be equal to the outside temperature, because there is always a exchange of heat. There is always a exchange of heat from high to low, but only up to equal temperatures. When the temperature get equal, then this flow will stop and the heat transfer will stop. So similarly, things will be happen to this object. This object will emit heat to the surroundings till the surroundings and these objects get the equal temperature. And when they get the equal temperature, the flow of transferring heat will be stopped. So as the things get colder and colder, it can cool down up to certain point, or you can say up to the equal temperature with the surroundings. And after this, the flow of exchanging heat will be stopped. Okay. So let's take an example. Suppose you have a glass of water and you put into the freezer. As the water gets colder, it turns into ice, but there is a point where it becomes really cold and it's hard to make it even colder. This point is called absolute zero and it is the coldest anything can get. So suppose the glass of water which you have, you put down into the freezer. Okay. This glass of water having a temperature of 10 degrees Celsius, where the freezer having a temperature of 5 degrees Celsius. So when you put, or you can say 0 degrees Celsius, basically as per the example. So when you will put this glass of water into the freezer, okay, it will start transferring heat from high to low, okay, and thereafter the time will come when this water will have a temperature of 10 degrees Celsius because it has transferred the heat to the surrounding, and then the surroundings will have equal temperature to the glass of water and there will be no further transfer of heat. So in this scenario, it will reach the absolute zero, or you can say the hardest or the coldest point of the water can achieve, or the thing could achieve. Got it? So this was the explanation for third law of thermodynamics. Now let's understanding the heat and work. Heat is the energy that makes things warm or cold, like the sun warming the earth. Work is when a force moves something like. So in this lecture, we had finished about the thermodynamics. In our next lecture, we will have a discussion over the electromagnetism. Okay, till then, thank you.